All right, welcome back. Hope everybody had a good break. Today we're gonna check out some stuff in Unity that people were asking about. Last time we have a few teams that are working on stuff that requires either like a joystick or some kind of movement system. And I went over a little bit how to do the accelerometer. The gyroscope's pretty much the same way, so I'm not going to go over that unless there's any questions. I haven't gotten any yet. But a few people have asked for guidance and stuff like writing their own joystick or moving the camera. And then I got at least one question on environment building, so I'm going to offer you a suggestion using Sketchup, which you don't necessarily have to use, but it's definitely one of the easiest softwares out there for that kind of thing. So when I'm done here today, I don't think I'm going to take the whole time, but I can if there are questions, so feel free to post in either chat if you want to hear any more about any of this. But if I don't take the whole time today, especially you guys who don't quite have an MVP or didn't quite have a nice finished product at the end of the last checkpoint, come and see me in the chat and I'll help you out with whatever problems you might be having getting your stuff implemented. And again, feel free to reach out with your questions so I can talk about your specific problem, whatever it is that you want to learn how to do. Because again, this world of Android is very large and covers a lot of ground. Okay, so let's say that you want to make kind of your own joystick here. So I've completely forgotten how to set my build to Android here. Let's hope I remember how to do it. Go switch platform. Oops, got ahead of myself there. Add this scene, cool. Looks good so far. I think that's everything I need to do, except linking that, there we go, any Android device. That should link to my Unity remote. Then let me pull up my device so you can see it. Okay, great. Make sure that runs before I move on. Alright, cool. There we are. And I'm going to make a little environment for my guy to move around. So your first option for creating relatively complex environments is going to be the terrain that's built into Unity. Terrain is really cool. It lets you do a whole lot of awesome stuff. You can... Oh my, this one is much bigger than I thought it would be. Okay. You can move it around. Let's make it smaller than that. 500 by 500. I'll move it so that it starts centered. If it's 500 by 500 big, then it needs to be at minus 250, minus 250 for the center to be 0, 0. You can note that from the camera's location here now. You can like paint grass on this thing and paint height on this thing and all other kinds of cool stuff, and it's awesome. So like you make mountains. Woo, mountains. Those are some pretty crappy mountains though. I reduce opacity, reduce the strength of the brush, increase opacity, increase the strength of the brush. So over here we have a beautiful mountain that I've created, and then I want to, let's say I want to smooth it out to make it less silly, so I'm going to smooth the height there. Looks less and less silly the more I do it. It's still clear that it's made out of stamped circles though, so let's take one of my more randomly looking shapes and use that instead. Make the smoothing effect stronger. Cool, I have a very pretty environment here. And you can do a lot of cool stuff with this, but if your environment's not outdoors, this isn't going to be super useful for you. What else can I do? I can paint textures onto this. I don't think it comes with any. Do I at least get grass or something? I don't think I have any. Let's see. Yeah, all I've got is UI sprite and background. Well, I'll just paint it in background, I guess. Built-in brush. Oh, redo. Okay, never mind. Anyway, you can paint grass and stuff and all that good stuff. You can make trees. Again, I don't know if I have any built-in trees. Nope, don't have any built-in trees. But are there any? Nah, darn. Maybe there's a tree. No, nothing. All right. Unity has a standard asset though that contains like trees and grass textures and stuff. You can import that from the asset store. I think there's even a special import for it here somewhere. So if you go to your imports, I think you can actually still import the standard assets directly. Maybe not. Nope, I guess not anymore. But yeah, you could import the standard assets from the store, and that comes with some grass and trees and flowers and details and other fun stuff. So this is one approach you could use. But again, that only works if you're outdoors. And terrains are cool because they're relatively low resource consumption. They let you paint the height really naturally and quickly. You can put nav meshes on them. That means that you can have your objects automatically do pathfinding and stuff. You can also put nav meshes on like the regular environment that I'm going to build here in a second too, but easier with terrain. So terrain's really cool. Try it out if you're thinking about outdoor, but let's go with good old cube floor here, which is I think what most people have gone with. And if you're building a 2D game instead, just imagine it's a not a cube floor, but whatever, the square floor. Yeah, I moved the sun up so that it wouldn't be underneath the floor. And set that to Y0. I'm going to center it, so it's 200 big, so minus 100, 100 centers it, or does it? Yes, that looks centered to me, so we'll roll with it. Okay, and then I'm going to make our protagonist here. Our main protagonist will be this cube. Alright, cubey. Let's move you into the camera. There you are, and I'll pan the camera up. And maybe rotate it down. So I think most game cameras are kind of like, they face down a bit probably. Like that. I think that's kind of the standard view from the camera. And then I had another question of like, how do you make the camera follow your cube guy as he moves around? So this is actually kind of a simple question. If your camera's a child of your cube, then it can automatically follow it around. And we can see that. I'm just going to do it manually. When we play the scene, as the cube is moved around the scene, the camera follows. It doesn't really look like much because the environment all looks the same, but when you get to the edge here, you can see the camera's just following me around, right? And that's all fine and dandy, but then somebody asked, well, what if the cube rotates, and I don't want the camera to rotate, which makes sense, because if I run this and then the cube, like, spins, that, obviously, I want the camera to track, right? I want to track the side-to-side spin, but then what if the cube, like flips? Obviously, I don't want the camera to clip through the floor and stuff. So that's a more complicated question. An easier thing to do it is to be like, there's like a parent object that tracks both of them. So this would be like the player object. The cube will be the renderer, and then the camera will be a child as well. So you've got your cube. This is going to be like the avatar, like the drawable thing that your character has. So this would include like all the colliders and the character movers and the rigid body and everything, maybe. And then you've got the camera as another child. And when you want to rotate, you would rotate the avatar around. So if I'm rotating the cube, there we go, that's fine. But then if I wanted to move, I would move the parent instead. So you just have two different objects that handle the movement and the rotation. So when you want to move, you move the parent. When you want to rotate, you rotate the avatar. So that's pretty much the easiest way to handle that. Let me draw a texture on my terrain here so that it looks a little cooler. And by cooler, I mean god-awful, because that's the only kind of art I know how to do. The awful kind. Waffle, waffle, waffle. That's gonna bug me. And you're always gonna want to use like a test pattern like this when you're first starting out with your program, because if you don't, then you're not gonna be able to like track movement and stuff, and it's gonna be awful. So just save that as floor texture. Let's make another, I guess, for the ball. Yeah, so it's not like you're using this for like the beauty of it or something. You're like using it because you want to be able to tell when your player has rotated or stuff, and if your player is just a featureless cube, then none of that really makes sense. You can't really tell if you're rotating in the camera if everything is just a featureless cube. So we'll be ambitious and we'll call this folder art, even though that's hardly a description of it. So we'll put the player texture in there and the floor texture in there. I'll make materials for both of those. So that's going to be the floor mat. That's going to be the player mat. Don't forget to check alpha's transparency if you use PNGs like me, although none of these are transparent, so it doesn't matter in this case. And remember, the albedo is the one that the material is applied to, so you drag that into the albedo there. Anybody know what albedo means in either chat? Anybody know what albedo means? It's a very uncommon word. What does albedo mean? Some people say albedo too. Perfect. Now we can see me move around this beautiful world. Nobody knows what albedo means? Okay, let's start on scripting to move around. Whoops. Delete that. Make a scripts folder. I'm going to make an empty object for my joystick. There's my joystick. Empty, empty, empty. I'm going to make a canvas that I'm going to ultimately draw my joystick on. So here's my canvas. I'm going to parent it to the camera. So it's going to work off screen space camera. I'm going to pick the main camera in my scene as its camera. It's just going to always be in front of it. This can be a problem on mobile. I'll show you here why, because obviously, I mean, you can already tell what the problem's going to be. The floor blocks our ability to see the canvas. We don't want that most of the time. So check it out. How can we fix that? Let's just try a plane distance of 1 and see if that works. All right, so check it out. I got the camera right there. This is one hacky way to do it. We'll see that that works fine, but I saw some of you had, like in the example I did last time, this. I think I briefly mentioned it, but I did this because, you know, we didn't have anything blocking it. But if you are going to do 3D like this and you still want to be able to see your UI and stuff, the easiest hack is just to move the UI closer. You got to adjust the size of all the UI components occasionally in exchange. But we'll see. All right, and then I'm going to have a sprite here, and this guy is going to represent the start of the touch. So I think everybody knows how joysticks work on mobile, but you've got like a little circle that appears when your thumb presses, and sometimes they're in a fixed place, and sometimes they're what's called floating, where when the first touch goes down, it uses where the touch starts and kind of spawns the joystick at that position. That becomes the starting point. And then sometimes the joystick center is always fixed. You can always see it on the screen even when you're not touching. Both of those are fine. Most games that are playable with your two thumbs, so games that are kind of like controller style, the expectation is that you are going to have the phone held horizontally, and you're going to have some kind of grip, and you're going to stay roughly in the same place. So in that case, the fixed joystick is better. But I'm going to do the floating one because I think the fixed one's pretty easy to figure out from there. So let's add a sprite here. Where's sprite? Sprite. I'll just use the built-in one of these guys. Use knob. And that's going to be the starting point of the touch. I'll make that a child of the canvas. It's vanished. I've made it too small. Touch, start. Oh, actually made it 0 small. Okay. Where is this thing? Why can't I see? Is it? Oh. That makes a lot of sense. Okay. It's Y for sprites. This is one of the confusions in Unity, is that normally you change Z, but if it's a 2D object, you change Y. It's, yeah, whatever. Irritating, but we live with it. Okay, touch start. Let's start writing the script. This is going to be joystick controller. And a lot of you found good joystick examples on the internet. You're welcome to use those, obviously. No rule against plagiarizing them. If you just give them credit, you can use them as you wish, but I find almost all of the ones online to have some defect, and I do want you to get into the habit of using both vectors and quaternions more freely. Okay, so if you'll recall from the touch example, we can get all of the touches from that touches array, which is a field of inputs. So let me grab the sprite as a game object. We'll call that start point. And I'm going to, if there is a touch, so if input dot touches, we can do touch count, or we can do touches dot length. Touch count has this extra guaranteed not to change throughout the frame thing, so let's roll with that. One thing to remember always about Unity is that it is a frame-based engine, which is different from what we're used to in like Java and Eclipse. Inputs can't happen within a frame. You're always looking at the delta between this frame and the last frame. Update occurs once every frame. It should be happening at least 60 times a second. Just something to always keep in mind. If you think of Unity as like a piece of film running through a film projector, so every frame completes all of its physics and stuff, and then it just kind of draws it to a single square of film. You can't move things in a square of film, right? The best you can do is tell the physics engine, please move this next time, and that's basically what you're doing. So everything's kind of read-only within a frame, if you think of it that way. Anyway, that's maybe too much detail. So you can get the first touch. Generally in games, the first touch is going to like move you. If you have like a 2-joystick game, you've got like your left joystick moves you, and then just touching the screen with your right finger makes the camera move around. I think that's the most common way I've seen it. So if input touches of 0 is touch phase began, touches of 0 is the first touch, which is probably your left finger. Then we want to place the starting point where your left finger is at. How do we do this? Well, it's remarkably complicated. So how do we get the point that you touched as a point in 3D space? You touched a 2D screen. How do we get the 3D point in space where you touched? Any ideas, either chat? 3D point in space from 2D point you touched? We did this last time. We did camera dot main dot screen to ray, and then we projected a ray. I think we struck the canvas with the ray, and then we made fireworks at where it hit the canvas. But raycasts are pretty expensive. It's a physics operation. It needs to do a line. There's like intersection and other math wizardry. So that's not great. How do we get the point that you touched in three-dimensional space? Any of you who have joystick examples already, feel free to look at them. You can cheat here if you want. See if they did it. How do you get the point of touch contact in three-dimensional space? Now, that's something I want you to think about for character movement too. You'll notice this from any big-name mobile games too. You only move in 2 dimensions. Forward, backwards, left, and right, and all the diagonals involved. Very few games let you move in 3D. If you do move in 3D, you have to have like a 2-joystick setup. You really have to think about it because it's not simple moving in 3 dimensions. And if you do want to move in 3D, what you usually do is have some kind of jump button. And how do you have a jump? Well, you probably have a separate button for that. Someone said my joystick was basic. Okay, your joystick was basic. It still had to get the point, though. It can't do magic. I've seen a lot of the joystick examples online. They'll make a rect transform or something like that. And then they'll either like raycast into that rect transform. This is especially for the fixed ones. Or they'll convert there's a method on rect transform to convert a world point to a point inside that rectangle. So they'll use that. So those are really helpful. I've seen a few joysticks like that. So they'll have one, like the outer part as a rect transform, and then they get the point that way. Anyway, I'm not going to torture you with this. I'll just answer it. It took me a while to read it too. So you've got a point on the screen. There's already a method in camera for screen to world point. And then you want to convert the X and Y position of the touch into a world point. So we're going to do input dot touches of 0 dot position. You can get the touch there. Okay, that's a vector 2, actually. Okay, because it's 2D. There's no Z component. Again, 2D touch. So let's see what that gives you. I have to add my touch start to my joystick controller. So add that script there. Touch starts the thing I'm moving around. Let's see what happens here. Touch, and you know, I have this other little circle that marks my touch point. That was my bad. Should I turn that off now? Alright, anyway, you can see touch start is just jammed up on the camera here at x0. As I move around, he's still stuck there. Not going anywhere, poor guy. He's jammed up on the camera. And what's wrong with that? Well, can't really do much. In fact, no matter where I touch, he's just stuck on the camera there. Let me restart and see what happens to touch start as I first press the screen. So he's just hanging out there at the start of the program, and the moment I tap the screen, it just gets locked in there. So that's not great. And obviously the touch is right up on the screen. So let's try this a little bit differently. Let's try a 3D vector instead of a 2D vector, because screen to world point should take a vector 3D. Alright, so if it's a vector 3, but I'm only dealing with a 2D position, so I want its x to be the x, I want the y to be the y, and then let's say I norm it on z, set it to 0 or something. Let's see what that looks like then. Vector math is fun, right? Whoa, okay, now it's just jammed up on my screen there. That's no fun, is it? Still sitting there. Okay. And okay. Let's get rid of this, the began, and just track it as my finger stays on it, so I can actually move it around. That's more visually fun. Nothing. Okay. So it's not moving around. That's no fun. Let's see if maybe I can set the camera and move it. So I don't have to keep calling camera.main as well. Helpful too. And the canvas doesn't have to be a child of the camera anymore either, because they are now linked through the camera's interface. Put the camera there. Okay. So I have my little joystick here, and the camera it uses is that guy. Okay, let's see if that's any better. Still gone. There's a little touch star just hanging out at the top still. So still doesn't really work. Alright. Try overriding it to 50 and see if I get anything different. See if I get a different position. Oh, look, now it moves around. But where is it? Let's go look. It's all the way out here in the ether, very far away. In fact, so far away we can't even see it on our screen. But it's moving around down there somewhere. Let's see if I can turn the... No, I don't have anything to visualize it better. But anyway, it's out there. You can see its position's updating. It's floating around the ether there. Okay. Not exactly what I wanted from it. Alright, so I want it to be right up in your face on the z-axis. So what I would do to accomplish that is I would just set the z manually to where it's supposed to be, which is 10. What did I set it to? 1? 1, I guess. Let's try 1. Alright. So after I've set the global position on this camera, I'm going to set it to start point dot local position vector 3. And then I'm going to keep its x and y because those are based on the touch point thingy there. And then I'm just going to set its z manually to 1 and see if that looks better. Still out there in the ether, floating around. Okay. Alright. Sorry, consulting my notes here. I was actually supposed to be the conclusion of it. It looks like I made a typo there somewhere, so just bear with me for a second while I figure out what's wrong with my vector math. X, Y, blah blah blah. Obviously, if you can spot the error, let me know. Looks like I have everything here. Maybe just do the classic top length here. Maybe that's the issue. It's floating out a lot further than it normally does. Let me just confirm with my notes there real quick. Not even on the screen. Well, that is bizarre. I think that the rotation of the camera is probably making this messed up. So let me probably just move it out into world space here. I think I might also have changed my camera settings here incorrectly. So let me try that too. Nope, it's definitely floating about out there. Alright, I'll run through the previous example and check if I changed my camera settings here. Because script-wise, I am exactly the same here. So, I have a camera, skybox, all the same, yeah. And then I have a canvas here somewhere. Where's that thing? Oh, it's a child. There's a canvas, child object, and my test sprite. Oh, yeah, that's the problem. I'm not supposed to parent the test sprite to the canvas. Darn. Okay, my bad. Alright, so sprite not parented to the canvas. This should probably do the trick. Let's see. Yeah, it's still parented. There it is, floating around down there. Just have to move it up so it's not stuck in the floor. Okay, so I can close out of my other example there. Alright, so now that it's not parented, I can go back to playing with it. So first I'm going to undo some of the junk that I was trying to diagnose this with. So the canvas back to being, let's call it planar distance 1 there. That means I have to set up my touch point accordingly. So right now it's floating out in space over here somewhere. I gotta bring them up to actually be on the screen so I can preview this. All right, move them over there and over here, and that's almost inside the camera. A little further back, and not quite there on the Y, and a little over here. So it looks like 0. Where's my camera at? 4 or 3.5, sure. 3.5, and then there he is. Okay, so that's just a start. And then in my script, I had the position at 50 in the previous example. I want it to be 1 away because I want him to be in the same place as the canvas. So now my little sprite guy should float about. Where is he? All the way over there. Yep, there he is. Okay, and then I need to change my world space transformation back to 50. And should be bouncing around somewhere close by. Where is he now? Oh. Can't have a rotation on him. Ah, he's still through the floor. Okay. Guess I can't have a rotated camera if I do this. That's disappointing. There he goes. Whee! Okay, so you can touch parts of the screen and watch them pop up in those different places. Alright. Okay, I need to do some other stuff there. Parent the canvas. No, I don't know what I did. Alright, for convenience, I'm just going to pop over to the other project rather than just to debug this. I think it did enough attempting to debug it for now. Pop over to the other one and go from there. Code's the same, I just have the camera positioned a little differently, and it looks like it doesn't like that. I mean, here I also actually have the camera set up pretty much the same way. So this is the old like tic-tac-toe example with the accelerometer. I just added the joystick to it. So you can see when you touch it, it just pops up in different places. There you joystick, joystick, joystick. And if you rotate the camera, let's go with like that. See, it still does it, so looks like I just messed up a setting somewhere in the other one. There he is, popping around. I'll show you on the phone as well. You can track my touches as a circle. I made it a square here so I could differentiate it from my circle touch thing. So there we go, different places it's popping up. Alright, so yeah, I'll figure out what the problem is with the other project's configuration, but it's not worth trying to debug it live. Alright, so back to the joystick code then. I don't need this one, but it's the same. I have it as joystick controller here. The only difference is I jumped ahead a little to the next part. Alright, so that's the starting position there. So I've got the, if it begins, it sets the little point. That's not all you need for a joystick though, right? You need the end point too. So let me make a game out of it. Usually when you have those joysticks in these kinds of games, you do have like the starting point as a sprite and you have the ending point as a sprite too. So, and then this I'm going to use later for rotation. So that's still your first touch though, right? Because it's the first touch locks the joystick in for a floating one, and then as you hold, it will continue to update the second point. So I'm going to save, well, I can copy this. So that's the touch phase moved. And then we're going to do the same thing, but for the second point. So, wow, everything did not go well there. Okay, that's going to be for the end point here. End point, end point, end point, end point. All right. Whoops. Okay. God, I had a game manager object here. Okay, so let's make an endpoint object 2. I have my little guy there. So be that end sprite. So be that start sprite. I'll make the end sprite a different color to differentiate them. So that guy can be like cyan. Cool. Move them next to each other to start. Okay, so on my joystick, if I add my end sprite, you can now see when I play that I lock in the point with my first tap, and then with the second tap, that actually determines like the joystick position. So you can think of the white square as the center of the joystick because it locks in when you touch, and then the other guy is the second point where your finger actually is as you're using the joystick. And since it's a floating joystick, you can use it anywhere. For a static joystick, obviously you just put the first square wherever and then you go with it. But how do you actually use this to move stuff around? That's the question. So let's solve that next. I'm going to have to make a floor over again. So there's my floor. I'll just scoot it down since there's a bunch of stuff inside my floor, so I'll put it at -10 to avoid having all that stuff inside my floor. I gotta bring my cool art assets back. My player texture, my floor texture. Floor mat. The player mat. Okay, set the tiling to something bigger. Tiling is how often the texture repeats itself, by the way. So if you want the texture to repeat itself more often, you get a better resolution. You get especially if your texture is low res, the more often you repeat it, the less stretched out it looks. And if you have a very high resolution, texture, you might actually make the tiling less than 1. You might want to stretch it over the body of your object. Let's make our player here. He starts down at -9, 0, 0. He gets the player mat there, and then I'll start him on camera here. Cool. Okay, so now he's on camera. And I want to move him when the joystick moves. So I want to move my little player guy when the joystick moves. Now to do that, I have to find the vector between the 2 points, the start point and the end point. So let me write a method for that so it's not too crowded. In the update here, we'll call that move player, and this would probably be a script attached to player instead of attached to this like joystick controller thing instead, but you could put it here too, it doesn't matter. And I want to get the magnitude of the vector between them, and usually I want to clamp it too, because there's a limit to how much you want to move in the joystick. So you don't want to be able to, let's say, tap the bottom left corner, move your thumb all the way to the bottom right, and then you can move really, really fast. There's like a limit to the running speed. And other games don't have any kind of magnitude at all. It doesn't matter how hard you hold the or how far away you go from where the joystick started. You're going to only move at a certain maximum anyway. So let's look at how you might do both of those. So first you're going to want to probably compute the distance between those 2 points in 3D space. This determines a couple of things. First of all, you want a dead zone. And a dead zone is kind of like maybe an accidental touch, but like if the distance between those 2 points is very, very small, then you don't want to assume that that's a deliberate attempt at movement. So in the center of your analog joysticks that you're used to, like on an Xbox controller or something, you'll actually notice if you pick them up and try to use them, if you move the stick just a tiny, tiny bit, just not at all, like a couple of minutes, you know, nothing happens because they have a built-in, usually like a physical dead zone. They don't activate the actual like buttons until you've made a slightly more deliberate movement with the stick. And with more cheaply made controllers like the one on the Nintendo Switch, the dead zone tends to malfunction over time, and then you end up with drift. So the dead zone should usually be something really small. That's the zone where we basically ignore the touches. So float distance is vector 3, and we could actually just use vector 2 here because, you know, they're two-dimensional basically. They're both on the same Z, they're both on the same plane. So we want the distance between the start and end positions. And if distance is smaller than our dead zone, then we would do nothing here. So we'll just return, and that allows us to ignore very small movements. If the joystick should be capped, which is usually the case, we want to cap how fast you can move or whatever, then we're going to set your move speed to some maximum. So you can determine what's the furthest away from the stick that you can be before you consider that to be the maximum. So call it like max distance, and that can be a larger value. I'm not actually sure what a good range is here, so we'll start with 20. So if you are smaller than that, then the magnitude of your movement matters. That's particularly for games where you want to support the ability to walk and run. So if the distance is smaller than max distance, we're going to get into the actual movement of the player here too. So we add the player as an object. There's my joystick. There's the player. I'm going to add a rigid body to the player too, just to show you an alternative mechanism for moving them here. Give them a mass of, let's say, 50. and just verify that he doesn't fall through the floor when I start. So yeah, it looks good. Alright, so if the what am I doing here? I have to call move player at the end of this. And then if the distance is less than the max distance, I want to move the player in proportion to the magnitude that your stick is held down at, or your joystick is held down at. So I want to move you in the direction that the stick faces, and again with the magnitude. So the magnitude is basically that distance. You can also get the magnitude between two vectors with vector 3. Magnitude will tell you the magnitude of the vector, and you can get the vector between the two by subtracting them. So that's a little bit more complicated, but avoids having to use distance. So I want to just move the player. I can do player.transform.position equals new vector 3, and then I'm going to update the players, let's say just x and y position. So our little guy can move on x here, and he actually can't move on traditional y, that's up and down, right? So he actually moves on x and z. And I want the left and the right on the joystick to translate to z, and the up and down to translate to the x position. So there's actually some remapping to do here because I'm using the x and the y position to determine the two positions of the start and end sprites. You see that as they move around, it's not their x and z position that changes, it's their x and y position that changes. So for the end sprite, for example, see it's the x and the y position of the end sprite that changes, but I'm trying to map that onto z, so a little bit confusing there. And I'm also not mapping their absolute positions, right? I'm mapping the difference between their positions, so that's confusing. Alright, so the vector between the two of those guys, that's going to be, I guess I'll just call it diff. That's endpoint minus start point. Okay, just I guess for fun, let's see what happens when I just add diff to the... Oops. Oh, not vectors, duh. Keep forgetting. Okay, let's see just what happens when I add diff to the players. Here we go. Whee! Flew off into infinity. Where did he go? Where is he even? Probably on the moon somewhere. Oh, there he goes, flying off in space. Let's do that again. This can be real gentle. Goodbye forever. Oh? Like, I can kind of control it, right? But first of all, it's on the wrong axis. It's not moving on Z like I thought, and then obviously it's flying all over the place. It's too powerful to add the vector between them, especially to do it on every update frame. Okay, so I've got the difference, and I want to update their position. So new vector 3, and I want to keep the y position the same. So the y position is going to continue to be player.transform.position.y. That's not going to change. And then I'm going to add to the existing position, position.x plus diff.x. Is that going to work? Let's find out. Let's try that out. So it would be diff.y for the z-axis. So I did a little bit of transformation there. Let's see how that works. This will be better, but still awful. So here we go again. Now I can actually move on the z-axis. So I have transformed my movement onto the right axis, but I am still super duper duper fast incredibly fast, and I've also fallen through the world because as soon as I fell off the terrain, the rigid body pulled me down into the ground and I flew off the world. So you might say, well, okay, how do I make this vector significantly smaller? That's probably one of the better approaches here. Okay, well, one thing you could do is multiply by delta time, which will scale the vector in proportion to how much time has elapsed since the last frame. See if that's any better, and it gets you a little bit more gentler movement probably, but still incredibly, incredibly fast. One more time. Goodbye! So you still fling off into the world, and that's not great. So what else can you do? You might want to just scale it down a bunch. So you would just multiply by some float. This gives you like a player move speed limit. Try that. Not enough. Alright, let's go more. Okay, too much, barely moving. Oh, I actually didn't have that multiplication correct for delta time, so let's give that another chance. Delta time gives you how long it took for the last frame to compute, so it helps you to scale things in terms of how long it did. Now you can see that that's pretty smooth. Our guy can move around. It's not bad. That's not bad. If we wanted it to be even like slower or something, we can multiply by move speed. And so this basically puts a clamp on how fast you can move, and I said that distance was 20, so watch if I just move the joystick all the way up, I get nothing, right? I get no more movement beyond that 20 zone. So if you want to do that, basically like clamping the movement to as fast as possible, well then you would just do the same thing. But instead you would cap the magnitude to 20, so you can do something like clamp it here to 20. We would do diff like that, and then diff equals diff dot clamp or normalize. Diff equals diff dot normalize. Normalize clamps its magnitude to 1, and then we'd multiply by distance, and then we'd multiply by time delta time. I think that would work. So, yep, normalize it to 1, multiply by distance. And then multiply by delta time, and that should give us the maximum possible movement speed. There we go. Okay, so now you can only move as fast as that. Once you get to the max, it just clamps it. You can't move any faster, so there's an upper limit to the move speed there. Watch our guy move around. Cool. Alright, I guess I should do camera rotation too, because I think that was asked about. So let me just do camera rotation as well. I actually already pre-programmed it here, so a little bit cheating, but alright. So with rotation, again, usually you're going to do it with the other finger, and it's actually not so bad, but it requires a little bit of trigonometry, so I cheated a bit and peeked at how to do that. I guess we won't go over the trig now, and you can definitely look it up on the internet, but it's something you should probably think about. So I have the same system here. When you touch down on the first point, it locks in that position, and just to show you here, there's a different way to get, there's a lot of different ways to get the touches. You can get the array, or you can use get touch, and it'll return the touch of whatever from the array for you. So actually, it doesn't matter. I could do that. I could do it the other way. Fun, right? And then I'll just interchange them to show you. And then I lock in the point's position. I generate a placeholder angle, and then I'm doing some conversions there based on the screen's width and height. And I'll just show you what the result looks like, because I don't think we have time for the trig if I still want to show you how to make a scene. So when you press the left button, you can move around, so you're playing with that thumb. That's basically the thumb for that joystick. You see, because I put it 50 away, my little joystick indicators keep clipping through the floor. So I'm going to have to move my canvas a little closer up. You can see them up there if I use my joystick and moving my square around. And then my right finger, if I have the left side enabled, so I've made it so that only if the left side is enabled, if the first touches down. So if you're using the joystick, then the right finger rotates the screen around. And a lot of games have it, this is an inverted look too, a lot of games have it so that if your left finger is not down, you can also look. That's actually significantly harder to pull off because you have to determine the user's intent. And that's why a lot of those games that you play with two fingers, see, look at that, I just accidentally started moving the square with my right finger. A lot of these games that you play with two fingers will have a fixed joystick, because then it's really obvious. You can just check if the player touched inside of the joystick area, then obviously they meant to move. Otherwise, they look. So rather than doing touches of 0 is look, and touches of 0 is move, and touches of 1 is look, they'll do touches of anything inside the joystick is moving, and anything outside is look. So if you want me to do one of those examples, I can do that too. But this gets your primitive joystick the ability to look around, so you can traverse this whole environment. Say I want to go under this shadow here. Boom, here I am, hanging out under the shadow. There we go. Look at that, hanging out in shadow. And then I let go, and now my right joystick is moving me. Here we go, back in the shadow. There we go. Now, if you don't want to update positions manually, which is often the case, instead of updating the transform, this basically, you can do this. So comment that out, and comment that out. You can get the rigid body and then add force to it. In this case, I'll add a diff, and then you usually have to multiply it by something if your objects are heavy at all, so I'll try just 100 as a placeholder here. And you can add force in a vector direction. This lets you have actual physics on your player object, if that is desirable, because then they have kind of this gradual shift on the way up. Let's see, I don't think I'm adding enough force to this guy. I don't think I can overcome his static friction, so I think I need to increase this width 20 times. There we go. Look at him go. Whee! Woo! I have a rolling cube. Now, the reason that the cube is rolling instead of sliding is because I'm adding a significant portion of the force on the y-axis, because I forgot to norm them again. So if I really wanted to do this, I would have to add the force just like this. So I'd have to do another vector 3. In fact, I think I can copy it out of here. Okay, that's looking good. And I'm not going to change the other one just for time. So let's check this out. Now he moves without kind of being as rolly. He gets force on the Z. But still very cool. You know, you can get like a rolling cube. And you see how this is a lot more natural than the cube just sliding around. This is probably the preference the vast majority of the time. You wanna move your stuff with the force rather than with just allocating player positions manually. This is going to be the way to go, like 99% of the time. I forgot to multiply this. Let's just multiply it up there. Oh, 1000's really too weak to get the cube rolling. Disappointing. There we go. Okay. Now the cube can move on the z-axis too. Yeah, so you get a lot more natural motion when you use force. And there's also the option to use the character controller, which can be helpful if you're going to end up doing a lot of animation and stuff. So I haven't looked at that at all with you yet, the character controller over here. This is going to be most helpful if you're going to be using like nav meshes, if you need to be able to climb realistically and play animations in response to certain events. If you're primarily just doing simple motion, I would recommend avoiding it. It's also relatively hard to work with, so I'm probably going to stay away from it here. Okay, so last few minutes. I've gotten any questions, so I'm going to go with a little Sketchup tutorial on how to build worlds and whatnot. So let me go to Sketchup and show you how to do that. Now, the one downside to building your worlds outside of Unity is that then you have to make their collision by hand, basically, in Unity. And this is especially true for mobile. So for mobile, if you end up making the collision automatically using the mesh renderer, it's going to cost you a lot of resources, and that's not going to be great. So first thing you want to do is kind of get like a top-down view, and then there's a button to do this, but I forget. And kind of want to design what the layout's going to be in this way. So let's say that I want a nice long hallway, and the width of the walls doesn't particularly matter here since the user's not actually going to see the walls. But I'm going to use my starting person there as a reference. So I want a nice long kind of hallway to start with. Do that. I'll try to keep the width of the walls relatively consistent, but it's fine. And I don't know, let's say there's a branch out this way, and then a branch out this way, and then there's like a thing here. This is like a dead end, I guess. Oops. And, whoa. Doing some funky stuff here. Well, it's too thick for the person to fit through, so... Going back to lines. Okay, in this direction you have like, you just keep going, I guess. There, and then, let's do one more piece of geometry. Let's say you go like, to here, and then there's stuff there. Whoops. I definitely don't want the inside to close, because these are going to be our walls, ultimately. And then this should be like a finished area. Okay, something like that is your environment. Probably close it. You don't want small corners because then the player can occasionally clip through those. Those are a bad idea. So you'd have something like that, and then you want this to be three-dimensional. I'll get rid of my reference person later, but say I want this to be three-dimensional. So I want to select all the faces quickly. I remember there's a button for this. There we go. and then you just extrude them into 3D, and now you have an environment with walls. So select all faces, select connected faces, select, I can select everything. And then you just extrude them, and you're done. Okay, I forgot to select all, so I'm just going to suffer the shame of having to do it manually. I accept. In Unity, you would just make a cube for the floor. Now, the only downside to doing it this way is that although you don't have to make everything with the cube editor in Unity now, you still have to make the colliders for this. So if I was to... Not bad. Alright, cool, I've got my maze here. And again, just cubular floor, but if you wanted to make stairs or something, that would obviously make sense too. So if I was to export this, we would see that it's actually quite a few faces. So let me go to my art here. Try environment test. It's 170 faces. It's actually not bad. So even as a mesh collider, it probably wouldn't be that bad in terms of resources. Another thing you have to watch out for in Sketchup is that sometimes the faces won't face the direction you want. So this would be invisible in Unity because it's not marked as white, which means it's facing outwards. So in this case, I want to reverse it. I want to get all the faces in white. So again, I basically have to find all the gray ones and flip them so that the outside sticks out. So gray is the inside of an object and white's the outside. And then I also forgot to hold control as I was extruding them, so they got extruded without their bottoms. Don't forget to do that. It looks like I remembered a couple times and then forgot the rest of the time. So if you hold control, then the rectangles actually have their bottoms as well. And that's probably also why I don't have that many faces, because they don't have any bottoms. You could actually get away with not having bottoms depending on how you structure your floor in Unity too, but you don't want to do that because you don't know how you're going to do it in Unity and what it's going to look like if somebody notices that it doesn't have a bottom. And so there you go, you've got a nice complex environment. You can do the same thing to build like ramps and obstacles obviously too. So for the marble runner people, you can build a ramp and extrude obstacles into it this way. Very helpful thing to do. And this whole face reversing game can be a real challenge. Okay, I think I knocked them all out. So see, that wasn't too bad. Alright. There we go. And there's tricks I can teach you to make it so that you have to do that less often. Now you can see the grays on the inside of all of these, which is what we're going for. So if we exported this in Unity, we could walk around and it'd be a cool environment. Alright, that's it for today. Any questions, let me know. Meet with anybody after if you want, and I have nothing to lecture on next time, so I'll meet with you guys unless I get another question or anything. So unless anyone has anything they want me to go over, Android Studio or Unity, your pick, I'm just going to talk to you next time. So be ready to talk if nobody comes up with anything. Okay, see you next time.